Good morning, everyone. Good morning, everyone. I'm Preeta from CSE Cybersecurity Department. Now I'm going to present a PPT on the topic A-star search algorithm. What is A-star search algorithm? Yes, it is a powerful pathfinding and graph traversal method, and it is widely used in various applications. This presentation will tell you the essential principles behind it and its real-world implementation, and how it maintains the optimality through the use of admissible heuristics, and it also ensures the efficient solutions in complex navigation and decision making tasks. Okay. Then moving on to the introduction to A-star search algorithm. First, what is A-star search? Yes, A-star search is a graph traversal and pathfinding method. It combines the features of Dijkstra's algorithm and greedy best first search to find the optimal path from the start node to the target node. Okay, that is, the target node is nothing but the goal node. Then the basic components are: it utilizes a cost function, that is f of n is equal to g of n plus h of n, where g of n is the cost to reach the node and h of n is the heuristic estimate to the goal, promoting the efficiency. Then open set and the closed set. Here the open set, the algorithm employs an open list for the unvisited nodes and a closed list for the nodes that have been evaluated, and it ensures the nodes that are processed only once, and it also enhances its performance. Then moving on to the custom graph construction. Okay, here it is a small custom graph construction. Then the three are given. The first one is graph representation, and the second is heuristic values, and the third one is weighted edges. In the graph representation, a hypothetical graph with nodes and weighted edges are given, and in the heuristic values, a visual representation of heuristic values guiding pathfinding is given. Edges representing cost or distance for pathfinding is given. Here it is a short custom graph construction for the A-star search algorithm. Next, moving on to the A-star search algorithm execution process. As we already saw the overview of the A-star search algorithm, now we will go into the execution process. Okay. It finds the optimal path by evaluating the nodes using the priority queues, and it allows for the dynamic path reconstruction to reach the goal node. Now we will go deeply into the step-by-step procedure for the execution of A-star search algorithm. The step one is step-by-step process, and an example of the A-star search is given, and the nodes are evaluated at the step one. And in the second step, priority queue usage. In this step, the nodes are prioritized to explore the promising path first. Then going to the third step, it is the path reconstruction. The optimal path is reconstructed once the goal is achieved. Okay. Then we will see the principles of the A-star search algorithm. The basic principles are optimality guarantee, admissible heuristics, and the completeness. In the optimality guarantee, the A star is guaranteed to find the shortest path rather than finding the longest distance or the longest path. And it provided the heuristic used is very admissible. These are the main advantages behind it. Okay. Then the admissible heuristics. The well chosen heuristics can significantly reduce the search space and its time also. Thus, it maintains the optimality of it. Then, the third one is the main thing, that is the completeness, and it always found the solution if one exists, and it makes more reliable for the pathfinding problems. These are the basic principles of A-star search algorithm. Next, moving on to its real world applications. Then, the three basic applications are given here. There are more than that also. The first application is navigation systems, and the second is robotics and AI, and the third is game development. In navigation system, the A star is usually widely used in the GPS systems and the mapping applications for the route calculation. And the second application is robotics. It is mainly used in robotics for the navigating environments. Okay. Then third thing is game development. It is also used in many video games and AI decision making. These are the basic real world applications of the A star search algorithm. Then the summary and key points of the A star search algorithm, as we saw the overview and the graph construction and the application and benefits of the A star search algorithm. By using all this, we can conclude that it is a powerful pathfinding algorithm and it combines the cost and heuristic values to find the optimal path. As we saw that the graph constructions, it builds a suitable graph representation with accurate heuristics and weights also, and it also promotes a good A star demonstration, and the application and benefits are used in various sectors like transportation, robotics, entertainment, and showing its the impact. Then we then we see a small example of the A star search algorithm. Here the city map graph is given as an example for this algorithm, and the heuristic table is also given. Here the city graph example is taken as the example for it, and A is nothing but the start node and G is nothing but the goal node. From start node to goal node, it will find the optimal solution and the shortest path also. Okay. Here some process is given, and what is heuristic means it is a straight line distance from the start node to the goal node G. Then we will go into the step by step execution of it. We should start at A, that is the formula f of n is equal to g of n plus h of n. Here the f of A is equal to g of 0 plus h of 10. By performing this, we should get the value as 10. Then we have to expand the B. In B, f is equal to 30 and D, f is equal to 60. Then we have to choose B, and from B to C, f is equal to 60 and E, f is equal to 15. Then we have to choose E. Then from E to f is equal to 15. At last the G, that is the goal node, is found. How the optimal path found is from A to B to E to F to G, and this is the most optimal and the shortest path find by applying the procedure of the A star search algorithm, and the total cost is also found, that is 5 plus 3 plus 6 plus 2, the 16 units. From this execution, we can narrate that at each step, the A star selects only the node with the smallest total cost, that is the smallest f of n value. This ensures that the most promising path is explored first. Next, moving on to the conclusion of the A star search algorithm. Okay. The future and significance of A star search algorithm. It highlights the potential advancements in heuristics and algorithm optimization, and it remains as a fundamental technique in artificial intelligence and computer science. It also encourages the heuristic design and its implementation on algorithm efficiency, and it also emphasizing a strong foundation in understanding the A star search algorithm for the future developments. Then the conclusion. A-star serves as a bridge between the theoretical concepts of graph search and practical applications, and it underscoring its values in complex pathfinding challenges. Hope you understand it. Thank you.